Roberto. It's nice to meet you. I'm
Nice to
Ben.
meet you, Ben.
Oh, how do you pronounce your last name?
Beltrami.
Okay, and what sorts of you specialize in making glass sculptures,
Yes.
vases, lighting, all that sort
A
of thing?
little bit of everything, mostly vases and sculptures. Yes.
Okay. How did you get into glass making?
That is a good question. So I have a bit of an unusual life story because I was originally born not in Venice,
Mhm.
but in Brescia, which is a city near Milan. And when I was 16, I went to the US for an exchange student program in
Whereabouts
Arizona.
in Arizona? Okay.
I went there for 1 year in Arizona, and then from there, after that I was like hooked to the US, and so I went to a school in Connecticut for 1 year, and I finished high school there, and then I applied to college, and I went to college for 2 years studying physics at Boston University.
Oh, nice. I used to live in Boston for like 4 years.
Oh, cool! Yeah, I went to BU,
Nice.
and yeah, I was living right next to Kenmore Square.
Cool. Yeah.
Yeah.
I know Kenmore. I went there all the time. I used to
Yeah.
work at the Boston Museum of Science. So
Oh,
like,
cool.
yeah. So I know the area.
Nice.
Cool.
So yeah, after 2 years of physics, as a kid, I was always into crafting, burning, making, wood, metal,
Yeah.
everything that I could my hands on. And so I saw this exhibition at the MFA,
Mm.
the Boston's MFA, from Chihuly. And I was just like, hooked to glass. And I was like, oh my God, what is this? I gotta check it out. So I came home for summer break. And I came to Murano, which is, for Italian distances, it's kind of far from my hometown. For American distances, it's not. It's like 2 hours of car, which is nothing.
Yeah.
But for us, it's like really far. So I went to Murano, and I got there. It was summer, and I was like, okay, maybe I'll find an internship, and I did. And I found this internship. So I decided to take like a sabbatical year, which turned out to be just me dropping college. And I just moved here, and I've been here for the past 10 years. Yeah.
Wow.
And so, yeah, I started working in a lot of companies. I started with an internship, and then I worked in a few companies with different, glass masters, how I call them here, glass masters. And so I learned a little bit of a trade, and, my luck was having kind of a scientific background, because, like classic craftsmen are very, you do because you saw how to do, and
Right.
then you repeat.
That's just how it's always been done.
Yeah,
Why would you do it any different?
Yeah, it's like, that was like one of the questions that I would ask when I was like, learn. I mean, you always learn in this kind of craft, but when I was like kind of like an apprentice, I would ask, why do you do this way?
Right.
Like, well, because I always did it like this. What kind
Right.
of question is that? And
So,
yeah,
like-
so for me, like physics was like a lifesaver, understanding, applying both, the manual aspect of it and the scientific aspect of it, understanding, heat transfer and how things work. And eventually, it didn't all come together right away. It took time to put the puzzle together, but over time I got like a pretty good understanding of glass just out of my physics background. And, that helped me learn a lot quicker than normally people would here in this trade. And then 4 years ago, I was like, you know what, there's no space for young people here because everybody's like a super jealous, artisan. They're like, oh, if I teach you, you're going to steal my job, blah, blah, blah. So I was having a really hard time. And so I decided to start my own company. And so that's what I did about 4 years ago. And now, we're growing a little bit. And we just moved to a new studio in January of this year. Well, not this January, last January.
Yeah.
So it was 1 year ago. And we're about, I have 1, 2, 3, 4, 5, 6, about 7 employees.
Wow.
And so it's been quite the adventure.
How, I mean, you just started like a year ago, right? And now you're up to 7?
No. 4 years ago.
Oh, 4 years. Sorry.
4 years ago. Yeah. The first 3 years we were in the first hot shop that we had, first studio, and it was Yeah, it was very small, and we managed to do like some crazy things in there with like, we had nice furnaces. The furnaces were nice at least because that's something you can just like move out of a factory. So every place, right, every factory you rent in Murano will have furnaces for glass blowing. So we had nicer furnaces there, but the space was just tiny. And as we grew a little bit, we had to look for, a new place. And January of this year, we moved to a new factory, which is much, much larger. And
Cool.
that's about my story.
So you mentioned that you have like a physics background. Like how are you applying what you know in physics to glass? Like, is there anything that you're doing different that like a lot of people, like you mentioned, like, oh, the masters always said like, oh, like this is the way that you always do it. Like, what's something that like you've done and changed that like you feel like is different than what a lot of people do?
There's a lot of like facets to this. Like sometimes it comes to like a particular technique with a piece. That I think it's not just about the science. It's also about like the problem solving mindset that physics kind of like instills into you, and just understanding that okay, this is the problem. How do we solve it? Let's break it down into smaller problems and find a way to do it. So one thing is just the techniques on finding different way to get different aesthetics into the glass, different designs and stuff like that. And I'm excited about that. But right now, being a startup, the main goal is paying the bills and getting the company at least profitable a little bit so it can grow some more. And then I hope someday I will have a team that works for me that just makes production, and then I can focus on just art. But that's quite a few years away. Yeah. So the physics really helps with when we have a client coming in, it's like, oh, we want this design. And normally, somebody else in Murano would say, oh, no, that's impossible for the price that you're asking. For me, just like finding a way to make an aesthetic design into like a production process and make it feasible at that price. That's something that I really enjoy, and also something that physics really helps with.
Right. Yeah. That's awesome. I know that I don't have like a background in glass, and I'm pretty new to ceramics as well. So like I'm just starting to get into it, but my background is in computer animation, like 3D modeling and programming.
Cool.
So like so I'm taking a lot of the stuff that I learned from that, where like I'm designing things in 3D and like 3D printing them and then using them as like molds and that sort of thing for ceramics. Are like, I guess like is there something in glass? So I know that you said like, oh, like some people said that doing that is impossible. Like what sort of properties or materials are you working with that you're able to leverage your background in to do something that other people say is impossible?
Yeah, there's a lot of things. Like there's talking about 3D printing. Like last year, I tried to make. So there are these like sometimes the glass is hand blown, so you like shape it by hand, and sometimes you just blow it in a mold because it's faster, it has less tolerances, and it costs less, and the client is happy. Right. And so, but classically, like there's two types of material that you can work with for blowing molds for glass, and one is wood, which you have to lathe on a lathe and then cut and make it like an openable molds that you can blow into. And the other are metal, but metal molds are really, really expensive. Like you have to cast them in a what do you call it? A fusion place where they melt the metal, a foundry. Yeah. You have to get it from the foundry and then CNC it and then, polish it and then apply a coat, and then it's crazy expensive. Yeah. And so last year I tried 3D printings with metal, with SLS, some components. I don't have a SLS printer, of course. But
who just send it out to? Or?
Yeah. I send it out to Shapeways.
Oh yeah. I've used them before.
I they're the only one I tried, but they were really fast, really, spot on. So I can't complain at all.
Yeah. How big are we talking here? Like,
No, we're talking really small. Like if you go
Tiny.
over a certain size, like the size of a cup or even a little bit smaller.
Right.
Like it was the first one I tried was for this client in New York, the one I was telling you earlier. They wanted these like little globes, like about this size. I don't know, maybe 10 centimeters by 7 centimeters, and but the tolerance had to be really tight, and we had to make like thousands of them, and with a wooden mold, the glass eventually burns away at the wood, and so the volume becomes larger, and then the shape is not okay anymore, and we would have to replace the mold every like 100 pieces, so that wasn't feasible. So I thought, okay, this is the perfect size. I tried it. I 3D modeled it. I was even able to add some like ridges on the outside to dissipate the heat better from
nice.
after blowing the glass. And in the end, it costed less than a traditional mold would cost. And it does its job still today. It works perfectly. And it's about a year and a half. And we made probably like, 3,000-4,000 of these things in that mold. And the lead time was just crazy. Like it took like 2 weeks to have it compared to like a traditional, one made in foundry and CNC. It takes about 2 months to get it. So it's, the clients don't want to wait 2 months.
That's cool. Have you, I'm not, like you sent me some pictures of some of the equipment that you have. Have you looked at getting like a CNC or doing, like are aluminum molds a thing that, is that something that happens in glass or no?
Aluminum, I did try to make some molds in aluminum, but it's not the best material just because, when you go with a glass inside of a blowing mold, it's at about, 900, 1000 degrees Celsius. So that's about what?
Yeah.
So in aluminum, over time, if you do like a few pieces, it's okay. Like I made this one mold in aluminum for this like cone, but it's about like this tall, and about this wide, and I had to the aluminum. It's not that expensive, but it had to be like 4 times the diameter of a piece that I was blowing in order to dissipate the heat. And if I was going really fast with this production, I don't know, I would be worried to melt the aluminum eventually. I mean, it would take a long time to build up the heat, but usually other materials that you can use are, I don't know, I've been thinking to try some things with just like paper mache and then CNC it. Because basically, like what you do is you keep wooden molds dipped into water. So when you blow the glass into it, there's always a steam layer between the glass and the wood. Because the wood would just would just char the glass and leave marks on the surface. So you always dip it in water. And basically, you can do the same thing with paper mache. It has the same properties, absorbs the water. Maybe not as good as wood at retaining the shape, but if you put a paper mache and you find a good way to like mix it properly with the what do you call it, the glue, the thing that keeps it together, and then maybe
that's cool. Do you have a CNC in your shop? Or
I do have this 3D printer that I ordered with Kickstarter, and it arrived, and I started putting it together maybe 2 months ago, and I still haven't finished because my days are so long.
Oh no!
And now I'm playing with, I was telling you about playing with Arduino, doing this data logging with furnaces, and there's something kind of new to me. I did take one course one time in Arduino, but that was like 12 years ago. So
that's very cool. Like, how much of your time are you actually like spending in the shop, like making things versus like managing? You said you had a team of people. Like, how are you delegating that, and like who's working on what? And
so I have one guy that just takes care of sales, like marketing and sales, mostly sales, and then one person who takes care of paperwork, something I'm not very fond of.
Right.
And then I have one person who does quality control, packaging, and shipping. One person who does the cold working of the pieces. Sometimes I have to call another person in, but that's not like it's like a contractor. Right. And then I have 1, 2, 3, 4 people in the hot shop working with me. So we are 5 people in the hot shop, 1.5 people in the cold shop finishing up the glass, like, carving, cutting, polishing, drilling the glass, and then 1 person.
That's cool. I mean, I've never done glass glowing, but like I've seen like videos of people, and there's a show on Netflix actually that I just started watching.
Blown Away.
Yeah. How is that like a good representation of what it's like to be? No,
I mean, not at all. But last season when they were doing the casting for the second season, the one of the directors of the casting, I guess they wrote to a bunch of people in Murano, but they asked, participate, blah blah blah, and I ended up, making it through the selection. But then Netflix had the final word, and apparently they chose somebody else. I mean, it's better this way because I was really conflicted. Like at a marketing level, it would have been insane for my company. Yeah. But at the same time, it would have shot in February, March of not this year, last year. Right. And I had just moved the factory and I had some unbelievable problems with like furnaces and getting production running again. And I was like, I did it once, the second time it's going to be a piece of cake. And then it was a shit show. Oh no. But yeah, finally we are up to speed now.
Very cool. I mean, that's amazing that you made it that far, even in the process. But so what sort of what sort of equipment do you have in your hot shop that you use?
So we have 1, 2, 3, 4, 5 melting furnaces. So those are either crucible furnaces or tank furnaces, which means the tank furnaces, they have a burner that shoots the flame on top of the glass, and the glass just sits inside of a refractory that makes the bottom of a furnace. And the crucible furnaces are just like a big chamber with a burner almost close to the bottom level of the furnace, and the flame swirls around. And the crucibles are these, well, you know what a crucible is,
Yeah, I actually have a backyard foundry, so I melt down metals and cast things all the time. So cool. Yeah.
Yeah, that's awesome. I mean, I was always into fire ever since I was a little kid. When I was 2 years old, I burned the couch. So when I saw glass, I was like, oh my God, this is the stuff for me. Yeah. And so we have 4 crucible furnaces, and in 2 of them, we have 2 450 kilogram crucibles that hold clear glass. Then I have one with 6 crucibles that hold about 15 kilos of glass each. That's for colored glass. And then one with 3 crucibles, one that holds 150 kilos and the other 2 that hold 70 kilos. But that's something that we can change when we replace the crucibles at the end of the year. Right. And the big ones are for the clear, and the other crucibles are for the colored glass, depending on how much volume we need for our production. So do you buy your, I guess for materials, do you buy is colored glass really expensive, and the clear glass is really how does that work? Colored glass and clear glass are really expensive if you just buy them, but we make them from the chemicals. We have a batch room where we mix all the chemicals to make the glass. I mean, the biggest quantity, we have a supplier that sends us, the chemicals, the main ones are, silica sand, sodium carbonate, calcium carbonate, borax, sodium nitrate, and potassium carbonate. Did I already mention that? No, I don't think so. And creolite, and
So do you put those
in your ingredients for a clear glass?
Okay, so do you put those raw materials then in the crucible and then melt it down? How do you? Yeah. How does that process work?
First you have to weigh all the chemicals with a very precise recipe. And because otherwise, the glass won't have the same coefficient of expansion. Then when you put different melts together with a different COE, they will crack upon cooling. So we mix all the chemicals, and we have a big, what do you call it? Tumbler, mixer, whatever.
Ball mill? Or?
I don't know if that's the word. It's like a mixing barrel. right? Is that
Okay.
the word?
Yeah. Does it have like fins on the side? What is?
Yeah.
All right.
That's the smaller one we have. Then we have a bigger one that's slightly different in design, but that's the same idea. You mix the stuff together so it's very homogeneous, and then you crank the furnace up to about 1350 degrees Celsius, and then you start charging. Right now we are melting the glass in the company. Thankfully, now I found a guy that does the night work. For the first year and a half, I was doing everything. Like in the morning, I was working glass. In the afternoon, I was doing other stuff. And then at night, I was melting the glass. I was working like, I don't know, 16 hours a day.
Oh, man. So what other equipment do you have that you use for making glass?
Those are the furnaces that just hold the molten glass for gathering it and picking it out and blah, blah, blah. And then we have two annealers, convection annealers to cool down the glass. So those, they can go up to about 550 at most, but we'll work them at about 510, 520 Celsius, of course. To cool down the glass. So we put the pieces in during the day. The annealer is at 510. At that temperature, the glass anneals and all the stresses are kind of relieved.
So is that a fixed temperature? Like it's always 510 degrees Celsius?
During the day it is. And then at night when we're done with the production, we switch it to a cooling cycle and it'll cool down to room temperature. And depending on the thickness of the glass, it'll do slower or faster cooling. Like for, I don't know, like thin stuff like this glass, it can go down even in like 6-8 hours. And for like thicker stuff, like we have, I don't have anything here at home. No.
So you must use those two different, you said you had two annealers, right?
We have two because we work on one day and then it goes to cooling and the pieces usually will come out the next day. So on the next morning we work with the second one and we rotate them like that. Okay. Yeah. And then if we have to make something thicker, we'll do it towards the end of the week. So we can take like a 2 or 3 day cooling cycle. Like so sometimes we go up to 48 hours of cooling for some really heavy, like thick pieces of glass.
Okay.
Yeah.
So you tend to batch your work then based on like the thickness of the glass. That way, you're only doing the big pieces all at once, or you're only doing the thin pieces all at once. That way.
It's quite difficult. Yeah, I mean, ideally, that's how most glass companies do it. When I started the company, my idea was to be like different than other glass companies. Otherwise, what's the point of starting a company with doing everything the same as other companies? So we are very, very versatile. Just the fact that, I told you we have 6 + 3, 9 Crucible plus 1 of a little tank furnace. We have always 10 colors of glass always available. And that allows us to be super versatile in thermal production. Usually a company will have, a furnace for a clear and a big ass furnace for a color. And, they'll be like, okay, today we make the red, and they make the red. And then a client's like, oh, I want yellow. Oh, yellow will be production in 3 months. You have to wait 3 months.
Clients love that.
Yeah, exactly. And so, we are very versatile. Maybe we don't have such a competitive advantage in terms of like if we have to make big batches of work, we're not that competitive. But clients nowadays, they don't come to Murano to buy big batches of work. They'll go to Czech Republic, they'll go to India, they'll go to China.
Right. And somewhere where it's cheap and they can get bulk of whatever. You're doing the smaller quantities, but like
we can still do it at a very like production scale. Like we're very fast, so we can offer a good price, but we're also very versatile. Like somebody orders a design and say it's a prototype, they want it in 10 different color. Another company would, just like laugh at them, be like, no way, we're not doing this. Like, because they would have to do it on like 10 different days for one piece, starting the production for one piece. It makes no sense. So during the day, we switch production like, I don't know, like 20, 30 times, something that a normal glass company would say we're crazy. Right. It's actually like the only reason why we are working. And actually, we are one of the only companies in Murano nowadays that like over the last year of coronavirus has had work all the time. And so that's, I think that paid off. Yeah.
That's awesome. That's a really cool advantage that like you guys have is just that flexibility.
Yeah, and it's also about mental flexibility because
Right.
other people that I worked with, they'd be like, "Oh, one piece, I don't even want to make it." I'm like,
Yeah.
I know it's a pain in the ass, but you can find work like that. You can find orders. Otherwise, you won't do anything. You'll just sit and do nothing.
Right. Huh. So to get back to the annealers, so you reached out to me. I posted some videos about PyKiln, which is a project that I'm working on, which I'm focusing more on the ceramic side, making kilns and that sort of thing. But it's electric kilns, and it's really the same sort of thing that you're doing with annealers. And I'm sure
I also have electric furnaces that are the same kind of for ceramic, but I use them for like cross techniques, like a little bit of glass fusing. Sometimes I make the pieces in the hot shop, and then I put them holding at like 550 in the flat kilns with electrical resistances. And then when I have everything set in, I'll crank it up, melt everything into a plate. And then, I'm trying to make some, plates for tables and, furniture and stuff like that. But that's like kind of a new project. Yeah. So I guess like what I've run into, so I have two kilns. One, I bought like that full cost brand new, and it has the worst kiln controller on there. It's got a Bartlett 3-key controller, and it can store a grand total of 4 user profiles, firing cycles. So every time you change,
so I'm constantly like, and it's just awful to use. I don't know about your experience in the electric kilns that you've played with, but like everything that I've, granted, I don't have a huge ceramics background, but like, from what I've seen, most of the kiln controllers that are out there, like, were made in like the 80s and like never changed.
But even the ones that I use for furnaces are not that much different. Like they are basically PID controllers.
Yep.
And instead of just running on and off some relay that'll turn on the resistances, they send I guess it's a 4 to 20 milliamp signal to a power inverter, which in turn runs the blower that feeds the burner of a furnace. Right. And then the pressure of the air from the blower feeds a line into a proportionator gas valve. And so the amount of gas that goes into the burner is proportional to the amount of air. So the combustion is balanced. Yeah. And that's it. So you're basically controlling like a big ass industrial furnace with just one signal. Right. That's it. So it's just a proportional signal and not an on and off signal. Yeah. But it's not that much different. And these controllers that we're putting on our furnaces and annealers are Eurotherm 2408, which are already pretty outdated. But like when one breaks, it costs like 1,500 euros to replace one. Ooh, and we have to, there's one supplier on this island that works with all the glass factories. Yeah. And I kind of, he's a good friend, but, I have to find something cheaper for my company. There's no reason that it should cost that amount of money, like for what it is. I'm sure it has a lot of, it's an instrument that has a lot of potential, but it's not being used in whatever application we are using them into. Like you could literally like use a lot of other things. Yeah. So like I've been studying, like I started from like 2-3 months ago to do these things with Arduino and trying to figure out, if I can do it myself, blah, blah, blah. And then one day I found your video, and I was like, oh, this is awesome. I gotta write this guy. Yeah. So just for people who are watching this later, so PyKiln is an open source web-based kiln controller that runs on an ESP32. And the ESP32, actually I have one right here, is one of these guys. It's a $7 US dollar microcontroller that connects to the web, and you can turn it into a little mini web server. So what I'm working on is making a way to turn one of these guys into like
like the best Kiln controller out there. And so, a lot of the things that I'm focusing on is safety, number one, having fail safes, that sort of thing. But also just that flexibility. So I haven't even like thought about hooking this up to a gas line and an air blower and that sort of thing. But there's no reason it couldn't. Like, it's the same technology, the same, like, it's just measuring a temperature and it's driving an output. So like, maybe I'll make another mode in this later that's like a gas version. I don't know. We'll see. We'll see where things go. But yeah, I guess like what sorts of things that you have, like what do you have in your shop that you wish was better, and what are some things for this project that you want included or would love to see included in the final thing?
I mean, remote monitoring, of course, but that's already something that you can do with a web-based thing. I guess an actual like interface to, like when you're there, like sometimes I'm doing something else. So the guys in the factory, they have to, touch the furnace, and I can't think of them,
pulling up their phone.
Yeah, it's like that's just not going to happen. So if it's like a business environment where like multiple people have to deal with it, maybe having an actual physical interface that's easy to deal with would also be a thing.
So a question about that is, because I've been debating this for a while, like because the reason, one of the big things for not having that physical interface is like it allows, like you can reduce the cost of it significantly by utilizing like an existing device that someone has. But like, I get what you're saying about like, okay, yeah, there's people that want to check on the status of it and see how things are going. One of the things that I've done is like in the different circuit boards that I've designed for this is I've left like the I2C pins and SPI pins open. So I could add something in the future where it has like an LCD screen that just says like, this is the current status, the current temperature, that sort of thing, but not necessarily provide you the input to make changes. What are your thoughts on that? Would that be adequate for what you're thinking about?
I mean, if it's if it's a Kiln controller for like glass fusing and ceramic, I think that would be totally okay. Like if afterwards you want to take it to the next step, maybe think of it as a controller for, like different types of furnaces and kilns and electric annealers and stuff like that, or, gas fired annealers. I think, say, I don't know, the internet is down and something happens and you have to, touch the furnace.
I have a solution for that one. So one of the things that I'm doing with this is like, I'm trying to leverage as much existing like serverless technology there is. Like one of the things that I've switched before. So I used to have this running on a Raspberry Pi. And so it was acting as its own little mini web server. And so you would just connect directly to it. And one of the things that I've changed with this is only now responding to like API input. It's not actually like showing you the web page with all the interface and everything like that. So yes, it would require an internet connection. However, and the pages would actually be pulling from GitHub pages. So like it's hosted there. But however, I have a thing, I have a step in the setup process for this where you could self-host like a local web server. So rather than going out to GitHub, it could all stay within your local network. So if you lost internet connection to your ISP, it would still work.
But, like the solution could it just be like getting like a cheap phone, right next to the what do you call it, the electrical box of a furnace or kiln, and just do it like that. That would be okay.
That would totally work. And you could also have like a computer or a laptop like in the workshop somewhere that is connected to all of them.
Yeah, that makes sense.
And so that's why I'm kind of thinking.
Yeah,
like,
for me that would work. I don't know if for like I put myself in the shoes of other companies that I know from a place where I'm at, and I think like I'm not even kidding. I'm like basically one of the only people that blows glass that knows how to program the furnace controllers. Usually they have to call the tech every time they have to make a change, every time they have to do something. So I'm kind of a new generation compared to the people that work here. And so I have a hard time thinking it feasible for a more classic setup, more classic company. But for a modern company, I think, that would be totally okay. Yeah.
Right. Just having a laptop somewhere in the shop. Like, and you can monitor all of them through that computer.
Because basically you're only like when you have to pull data, you don't have to be in front of a furnace. It's actually a hassle to be in front of a furnace because it's hot. While if you're programming it, you only program it once, and and you can also do it from your phone. So it doesn't matter. Yeah.
Right.
I think it would work.
So the other thing that I've been thinking about too is like, I have the ability to import and export firing schedules. So for your setup where you have multiple annealers, multiple ovens or kilns, like you probably want those same firing schedules on all of them, Maybe
it's a little different, like the way, like for my kilns, the fusing kilns that are also good for ceramic, they work like that. But the furnaces, they run this little thing, the 2408 Eurotherm, and they are basically always running. Like we turned them on in September and we shut them off in July, and so they're always running. They have a set point which you can manually modify, and they also a manual mode where you don't input a target temperature which the PID controls, but you just input however much percentage of the output you want to go to the blower, which feeds how much power you want to go to the furnace. And then
so those two things are so one is just like hold this temperature all the time. And the other one is the one where
PID works. The PID works and says, okay, find the right percentage. While the other one is just set the power.
Right. That's actually really interesting because I mean, would you still want to have like something like this controlling that, or like that seems like you could get like there's a bunch of just PID controllers that you can buy off the shelf that you just set.
No. But I mean, there is another section where you can program it. So for example, tonight I'm melting the glass at the factory on two furnaces. So usually the furnace is holding at 1,100 degrees Celsius. Right before I left, the guy that was melting the glass arrived, and so I cranked the furnaces up to 1350. When he's going to be done charging the last batch of glass, which is going to be maybe at 2 a.m. tonight, he's going to hit one key, and then a program will be running, which will there are different things in the program, like you can ramp to a certain temperature in a certain time, or ramp at a certain temperature at a certain rate, or you can step to it, like just like skip to it. And so the program that I'm running tonight will skip it to 1350, which is the temperature I previously set, but just because I need to start at a certain temperature.
I see.
So I skip it to this temperature. I hold it there for about 6 hours in order for the glass to finish melting, refining, and getting rid of all the impurities. And then it will ramp down to 1,100 in about 2.5 hours. And then it will dwell there. I mean, there are different options at the end of the program. You can either go back to the temperature to which the controller was set before you started the program, you can dwell at the final temperature of a program, or you can set temperature with an operator can set the temperature that is set on the controller at the end of a program. So it's slightly more complicated, but it's nothing, crazy.
Okay. So it's more of just like scheduling the start, a ramp up, holding it for a long time, and then a scheduled ramp down.
Yeah. And that's for furnaces. On those controllers, I also use them when I first turn on the Crucibles at the beginning of the year. The furnaces are cold in August. We shut them off in July, replace the Crucibles once they cool down. And then in September, we start again. And to heat the Crucibles, we have to go very, very slow and careful because they are mostly aluminum. Yeah. And so it takes about a week to heat them up, and you have to go really slow. So
that's crazy. You just keep those like hot the entire year, like
24/7.
Wow.
Yeah.
Okay.
Because these kind of crucibles are really good at withstanding. Well, first they're unfired. So once you put them in, you have to fire them at 1450.
Yep.
And so you fire them and they become ceramic. They become amazing at withstanding, the thermal shocks of, charging glass every night. Over time, they do get used up. And so sometimes towards the end of the year, they'll get a crack, or sometimes they'll just straight up get a hole and they won't hold glass anymore. And so at the end of the year, we eventually have to replace them. If you were to turn it off, they're amazing at withstanding thermal shock, but if they go below 700 degrees, they will just crack. And so we can't let them cool down at all during the year.
What is that, electric or what's?
No, gas fired.
Gas?
Yeah, natural gas.
Okay. All right. And you're just getting that from like the city?
Yeah, the local supply. Yeah. I've been thinking about electricity, how to, run the furnaces electrically, but there's like a cost part of it, which like electricity in Italy is still way too expensive to do something like that. And also it's not really good for glass because with glass, you really need a lot of convection to, transfer that heat around the furnace and to melt the glass, while electric only irradiates the glass. And that, as much as that's a very efficient way to heat the furnace, because you can like, isolate the shit out of it. As soon as you open the door, like when we're working glass, sometimes we'll open the door and we'll keep it open for 8 hours. It'll just like, and you need a ton of power to keep it running with just irradiation. Yeah.
And then I'm sure, I don't know how many power outages you get, or like that could probably be very detrimental if you lose power for an extended period of time and there's nothing you can do, versus gas. Like it's always there.
Yeah, gas is always there. That's one thing. Although if power goes out, I had just like 2 weeks ago, I had what do you call it? UPS thing installed so if we have a power outage, we still have power, and it's like a battery section and then a diesel generator section. So because during the lockdown, there were a few power outages, which like never happened. And it was like brutal because, you're like, you find out somebody calls you from a factory who goes to check and we're like, hey, the furnaces are off. I'm like, fuck, if they go below 700.
There goes all your crucibles and glasses.
Exactly.
And like, oh my God.
And so run to a company, blah, blah, blah. And one day it happened while we were working on like a project on the electric kilns. So I had this big lost wax cast mold from an artist with like these beautiful bodies, and we had to cast glass into it. And so we do like 3 gathers of glass. We pour them into the refractory, what do you call it? It's not cement, refractory chalk, no, refractory plaster mold. And we pour 3 of them. We have like, I don't know, 6, 10 to go, and boom, the power goes out. And it's an electric furnace, so it's not like the gas furnaces will stay hot for like 4 hours. It's like, and the artist was there, and I was like, I don't know what to do.
Yeah. Wow. Oh man. So have you had any like problem outside of the power outages? Have you had any like problems or maintenance that you had to do? I know that you were saying that you were playing around with like Arduinos and programming your own custom thing. Like what sort of, Are you in there like doing all the maintenance on your stuff, or are you having someone come over and do the maintenance for you?
I have someone come over, but like my New Year resolution is to become more independent in that. So I've been studying every night to like be able to be a jack of all trades and do everything. Right. I mean, I can do everything, but I can know enough so that I don't have to call the tech every time, right. And then he'll invoice me for like a shit ton of time. Yeah.
So like how many? Like, are most of the people doing glass work in Venice? Are they're mostly the older generation, and you're kind of in the minority of like younger, more scrappy people that are like leveraging technology and that sort of thing to. Yeah,
I'm like the only one. I don't want to say like
the only one.
Be arrogant, but I'm the only one. Everybody here is so
all of Italy, just you.
No. All of the island here, Toronto. Like okay. It's crazy. Like if I never thought in my life that I would open a glass company, right. But at some point, like I had so many ideas and I wanted to try so many things, and everybody was so close-minded. I tried to find a way to find a collaboration with some factories where I worked at, and everybody was so close-minded, and I just couldn't deal with it. So I literally looked for every possible solution. It's only like 5,000 people living on this small island, not in Venice, but in Murano, which is a smaller island in Venice.
All right.
Yeah. And so I kind of know everybody, and everybody knows me, but nobody, like everybody still thinks that I'm gonna go out of business. They don't know that I'm not gonna give up ever.
Oh man, I hope you don't. I mean, it sounds like you're doing some really cool stuff, and like I feel like, I mean, like you have to change and innovate, and like if you just stick to the same stuff over and over again, like. You're going to get passed. Like someone's going to come out, like you're 3D printing some molds and blowing it. Like, yeah, of course. Why wouldn't you do that? Like,
no, it's common sense. I mean, I know it's, somebody said, if you're not failing, you're not innovating enough.
Right. Yeah, for sure. Oh man. So I guess, do you have any other thoughts or like ideas that you could send my way? Like, what are some things that we could do to make this thing like kick ass and be something that is like a viable option that people could use in their kilns? Like blows everything else out of the water.
Yeah, I think, I don't know, giving it the possibility. I mean, I think at my small world, I mean, I'm sure there's a ton of industrial applications where you need a ton of more functions. Right. But for my small case, I think the fact of being able to, to have a set temperature and then go into schedules programmed. Or just do the program without the, constantly set temperature. Like for my furnaces, have a way to add or remove alarms, like if something happens, like multiple alarms, like, I don't know, for the ones that I have on my furnaces, there's an alarm of over temperature, an alarm of under temperature. Mm-hmm. What else? There's other alarms, but they're like hooked onto relays. So it's like a different control. Like there's a whole like relay mess in there.
So it's like a safety thing. So like if it's cooling too fast,
there's like
fast, then it's like, oh, this is wrong.
No. It's more like a safety thing for there's a what do you call it? A pressure sensor, a pressure thing that says, okay, there's this much pressure. Yes, turn on. There's not enough pressure. Turn off. Kind of switch. It's a sensor. I don't know what the name of it. Pressure gauge. I don't know.
Is that pressure for the gas or what?
Both the gas and the air. So the system, the whole control box will shut down. Will shut down combustion and will close the two electrovalves that control the gas. If either the gas or the air pressures are missing. So if the air pressure is missing, that means there's no power. Or the blower broke or something else broke. If the gas is missing, well, it doesn't matter. I mean, there's no gas. So it's especially important when you're heating up the furnaces and you're not yet up to auto combustion temperature. So if the power goes out and the flame goes out and the gas is still coming out and the furnace is below, say, 700, 800 degrees, then you just have gas that is going into the furnace and then out into the factory. And then you don't want that.
Yeah. I don't think I'll run into that with like electric, but like good to think about. Like I definitely want to focus on like electric kilns for this first thing.
For the first part.
And then good to know, like, okay, fail safe for gas. Oh yeah, we lost pressure.
Yeah.
Stop.
So multiple ways to like stop it. So alarms, for like, I guess user programmable alarms that I don't know, that are maybe like hooked up onto the controller. I think I'll send you an email if I get any other ideas. So maybe we can do another chat sometime soon.
Cool. And then just so everyone can find your work, it looks amazing, by the way.
Thank you.
What's a good website? And I don't know what sort of social media do you use so people can follow you or find what you're up to?
If you want to do Instagram, it's at Wave Murano Glass with underscores in between the words. So it's Wave _ Murano, which is MURANO _ glass. And then, my company is Wave Murano Glass. So you can you can Google it and then you'll find it. Yeah.
Nice. Roberto, it's been great talking to you. And it's been nice to pick your brain and just kind of weigh things out. I can't wait to see like where this project goes and where it takes us. And, I appreciate your ideas and your time. Thank you.
No worries. It was my pleasure. I mean, if people that want to make something new, it's always worth spending your time. So it's a pleasure.
For sure. All right.
Yeah.
Thanks, Roberto. I'll talk to you later.
Thank you. Bye-bye.
All right. Bye-bye.